Welcome back to class. We have derived the ISLM model, and now we are going to apply the ISLM model. So we'll talk about an expansionary fiscal policy and an expansionary monetary policy. Let's do so. The black cross here, this characterizes the initial equilibrium. We are in our basic equilibrium where the GDP level is equal to 2000 and the interest rate level is equal to 10. Now we would like to find out what happens if the government increases government spending. Government increases government spending by 100 units. This shifts the IS curve to the right by 500 units. You can see here this rightward shift of the IS curve. And then it is the case that the new equilibrium is in the intersection of the IS curve and the LM curve. So an increase in government spending by 100 units increases GDP from the level of 2000 to the level of 2250, and the interest rate from the level 10 to the level 12.5. The interest rate increases by 2.5. What we can see here is that in a pure goods market model in chapter 3, the GDP would increase from 2000 to 2500. The multiplier would be equal to 5, so that an increase in government spending from 100 unit would increase GDP by 500 units. But here in chapter 5, it is the case that the income multiplier is smaller. GDP only increases by 250 units and not by 500 units. So the multiplier in this case will only equal to 2.5. Why is that? Why is an increase in government spending in this environment less effective in increasing GDP? The reason is that in this environment, the interest rate increases, and this affects the demand for investment goods. Demand for investment goods is lower than before, and hence this expansionary effect will be to some extent dampened. Let's talk about how do we get from this equilibrium to the other equilibrium. How do we get from the old to the new equilibrium? What is the transmission mechanism? We start at the initial shock. The government increases government spending. This leads to an increase in demand. Demand is larger than supply. The companies are producing more. The output increases, and hence the income generated in the production process will increase. This affects consumption. Consumption is up. And in the first step, GDP would increase like by 5 arrows here. We would have a multiplier equal to 5. But then we have to think about the spillover effects from the goods market to the money market. In case that GDP increases, it's a case that money demand is affected. Money demand is larger than money supply. When money demand is larger than money supply, this will lead to a situation where the private households want to hold more money. Where do they get the money from? They get it from the bond market. The private households are trying to sell bonds. Bond supply is larger than bond demand. This leads to a decrease in bonds prices, and this implies that the yield, the interest rate, increases. When the interest rate increases, this has an effect on money demand. The opportunity costs of holding money increase, and hence money demand is affected in a negative way. But now we also have to think about the spillover effects from the money market to the goods market. When the interest rate increases, this affects the demand for investment goods. Demand for investment goods is down. Therefore, we have a negative effect on the demand for domestic goods. Supply is larger than demand. GDP decreases. When GDP decreases, consumption is affected in a negative way. And here it is the case that GDP also decreases once more. In the end, when we combine this direct effect and this indirect effect, it is still the case that GDP increases. GDP increases by three arrows here. So in a pure goods market model, only the first line would be valid in order to explain why we have a big effect on GDP. But in this ISLM model, this increase in GDP has an effect on the interest rate increases, and therefore the effect on GDP is limited. Based on this result in the graph, we would assume that in this situation, the income multiplier of a fiscal expansion takes the value of 2.5. So the government increased government spending by 100 units. The GDP increased by 250 units. And therefore, in case that the government would only increase government spending by 1 unit, then GDP would only increase by 2.5 units. The income multiplier should take the value of 2.5. Let's check whether this is the case. Let's compute the income multiplier, and here we are going to use Chromas Rule. So we start with equation 73, where we have written the IS and the LM equation in form of a matrix notation. In the next step, we compute the total differential, which implies that we write a d in front of each variable. So in this step, it's really important that you know which kind of letter displays a variable and which kind of letter displays a parameter. The parameter are constant. We are not writing a d in front of a parameter, only in front of the variable. Also, when it comes to this kind of term here, for example, minus C1t, we are writing the d in front of the variable t, but not in front of the parameter C1. In the next step, we have to think about what changes in the solution vector. Here it is the case that we are looking at only one exogenous shock, which occurs in the variable g. The government increases government spending. All other exogenous variables are constant, and therefore the changes of these variables are equal to 0. So we only have one change in the solution vector, which is the change in government spending. In case that we want to compute the income level, we have to check what is the position of dy on this vector of the two unknowns. It's in the first position. Therefore, we have to take the elements from the solution vector and insert these elements into the first column of the coefficient matrix. So we find the elements from the solution vector here and there. Now we have to compute the determinant of the numerator and the determinant of the denominator. dg times minus d2, pg minus d2, minus 0 times b2. And then in the denominator, 1 minus c1 minus b1 times minus d2. And then in the denominator, 1 minus c1 minus b1 times minus d2, minus d1 b2, which is here. In the next step, we have to check this one here is 0, so this part drops out. Then we can write this d minus d2 in front. In the next step, we can divide by dg. We put dg on the other hand side of the equation. And it's also the case that we have a negative sign here, a negative sign there, a negative sign there. Like these negative signs will drop out, and here we'll have a positive sign because these negative signs can be cancelled. Then we multiply through the right-hand side of this equation by this expression 1 over d2, 1 over d2. When we multiply through by 1 over d2, we'll get a 1 in the numerator. This d2 will cancel out, and we'll find a d2 here in this denominator. Now we can check whether this expression is positive or negative. It's the case that this expression is positive because we only have positive elements here, and the term in brackets is positive because we assume that the sum of C1 plus B1 is smaller than 1. So the whole expression is positive, and therefore we can interpret this relationship in the following way. If the government increases government spending, then GDP is affected in a positive way. GDP increases. By how much does GDP increase? Let's plug in all the information we have, like all the information for these kind of parameters here. Then we get the result that dy over dg is equal to a positive 2.5. This is what we expected, so that when government increases government spending by 1 unit, GDP is up by 2.5 units. And in case that government spending is up by 100 units, then GDP is up by 250 units. Of course, what follows now is the interest rate multiplier. We also want to confirm that the interest rate reacts in this way, that the interest rate increases by 2.5 units. So here we start directly with the part where we already have the total differential and we only have a change in government spending. Now the interest rate is located on the second position. And in case that the interest rate is on the second position, we have to take the elements from the solution vector and insert them into the second position of the coefficient matrix. We have to multiply through 1 minus C1 minus B1 times 0 minus D1 dg. The numerator is known already. We have a 0 term here, and this will drop out. And we can write this minus D2 in front. We have a negative sign here, a negative sign there, a negative sign there. These negative signs will cancel out and we'll get a positive sign here. We also put this dg on the other hand side of the equation, and we have computed here the interest rate multiplier of a fiscal expansion. It's positive. We have a positive sign here, and hence this implies that when the government increases government spending, this will increase the interest rate. By how much? We have to plug in the parameters. Then we learn that the multiplier takes a value of 0.025. So when the government increases government spending by 1 unit, then the interest rate is up by 0.025 units. And here we have a larger shock. So the government increases government spending by 100 units, so that the interest rate will increase by 2.5 units. This is the end of this part of the lecture. Take a short break and we'll meet in one last video. Thank you very much.